Welcome back, everyone. In this video, we will learn how to determine the required sample size for estimating a single population mean. So recall that we learned about the three conflicting objectives when we are developing a confidence interval estimate. So as a refresher, for a given sample size, a high confidence level will generate a larger margin of error. For a given confidence level, a small sample size will also result in an increased margin of error. So if we want to reduce the margin of error, we either are going to have to reduce the confidence level, increase the sample size, or both. So to determine the required sample size for when the population standard deviation is known, we first need to review how we calculated the margin of error denoted by the letter E. To find it, we take Z times our standard error. Now, to determine the required or minimum sample size, we will then solve for n, and we get this formula here. So in the numerator, we have Z, and this will depend on the confidence level. I have included the same commonly used confidence levels here for reference again. In this first example, the population standard deviation will be known. So then in the denominator, we have the margin of error. So we will take Z squared times the population standard deviation squared, and then divide by the margin of error squared. Here's an example. The Emergency Medical Response Unit in Oceanside is interested in estimating the mean time to respond to an emergency call. The times are assumed to be normally distributed with a known standard deviation of 2.5 minutes. If the agency wishes to develop a 95% confidence interval estimate for the population mean with a plus and minus 0.5 margin of error, what sample size is needed? First, we need to identify all of our variables. So the Z value at 95% confidence is 1.96. The standard deviation is given to us at 2.5 minutes. And then the desired margin of error is 0.5. So here we have a formula again. So we just need to plug in our numbers and solve. So we will square 1.96 and 2.5, then multiply them together, and then divide by 0.5 squared, and we get 96.04. Now, since we'll be selecting a sample of emergency calls, and you can't have a partial call, we will always round to a whole number. Also, we will always round up to ensure the sample size is sufficient to give us the desired margin of error for the population mean. So let's take a look at another example. The American Dairy Institute wishes to develop a 90% confidence interval estimate for the mean number of gallons of milk consumed per year by a family of 4 in the United States. They wish for their estimate to be within plus or minus 3.5 gallons. The population standard deviation is unknown, so a pilot sample of 50 families is selected, and the sample standard deviation is 62.5 gallons. So running pilots is a common thing to do in business and in research, where we will sample a small group first to test and see how things come out before we do our full study. So again, we will identify our key variables. So the Z value at 90% confidence level is 1.645. Since we don't know the population standard deviation, we will use the sample standard deviation of 62.5 instead. And the desired margin of error is plus or minus 3.5 gallons. So here we have our formula again, so we just need to plug in our numbers and solve. We will square 1.645 and 62.5 and multiply them and then divide by 3.5 squared, and we get 862.89. So same as before, we'll round that up to 863. Now, since we selected a pilot sample to establish our sample standard deviation, we will then subtract the 50 to arrive at a net required sample size of 813. Let's go ahead and wrap this up with a practice problem 8.29 from the textbook. A manager wishes to estimate a population mean using a 95% confidence interval estimate that has a margin of error of plus or minus 44. If the population standard deviation is 680, what is the required sample size? So first, we want to make sure we identify our margin of error. So that is given to us as 44 in the story. So the population standard deviation is also given, and that is 680. So next, we need to determine the critical value. So the confidence level is 95%. So if we go to our commonly used z-value reference table, we know that is 1.96. So here is our formula again, and we just need to plug in the values. So we plug in 1.96 for z, 680 for the population standard deviation. Then we'll square both of those numbers. Then in the denominator, we'll plug in the margin of error of 44 and square that. We will plug these into a calculator and we get 917.54. Always remember to round up and we get a sample size of 918. Well, that wraps up this short video on determining the required sample size for estimating the population mean. In the last video, we will close out the chapter and work with population proportions.